In this video, we're going to be doing some examples of actual hypothesis testing for one population mean, that mu. Here's an example. A used car dealer says that the mean price of a 2008 Honda CR-V is at least $20,500. You suspect this claim is incorrect and find that a random sample of 14 similar vehicles has a mean price of $19,850 and a standard deviation of $1,084. Is there enough evidence to reject the dealer's claim at an alpha level of 0.05? Assume that the population is normally distributed. So here's the first thing we need to do looking at this statement. We need to figure out what is the hypothesized mu that they're telling us in the problem. And in this case, they suspect, or the used car dealer suspects, that it's at least $20,500. So that statement right there is your actual mu that you're going to use for your hypothesis statements. Now, looking at how it's worded here, at least $20,500. At least means it can be $20,500 or it can be more than $20,500. So that's actually a greater than and equals case. It can be exactly $20,500 and it might be more. So that means that's our HO. That's our claim. And it makes sense that it would be our HO statement because it has the equal sign. HA is going to be the exact opposite of greater than or equals. And that's just the less than sign. So they told us in the problem that the alpha level is 0.05, and they told us that our degrees of freedom, they told us our sample size is 14, so therefore our degrees of freedom is n minus 1, which is 13 degrees of freedom. So let's look up our rejection region on the online calculator. So we have 13 degrees of freedom, and they told us the alpha level is 0.05, and we say calculate. So of these two critical value options that are given to us, we know that it's at least going to be a one-tailed test because our HA statement was mu is less than $20,500. So it is going to be a one-tailed critical value, but it's going to be left-tailed because the less than test is always the left tail of the t-distribution. So our critical value here, our critical t-value, is negative 1.771 if I'm rounding. And let's just make sure that that's what they get in the slide using the table approach. So here's our t-distribution, and yes, they get the same critical value that we get. The critical t-value is negative 1.771. And you can see that they've shaded in everything to the left of that critical value in blue. That shaded blue part is our actual rejection region. So what that means is, if the standardized test statistic, if our t-value that we calculate in our if our test statistic that we get in our graphing calculator falls in this blue shaded region, then that's enough evidence to reject HO and get rid of that claim. So how we do that, well, we can plug it into the formula. Okay, so the sample mean, which was $19,850, minus $20,500, which is our hypothesized mu, divided by, there's our standard deviation in the problem, 1,084, and that's divided by the square root of the sample size, which is 14. So we should get a standardized test statistic of negative 2.244. And if we look where that falls on the rejection region of this t curve, basically, yeah, that t-value does fall in the shaded rejection region. So because our standardized test statistic is in that shaded rejection region, that means we can reject the HO. The HO is no mo. And that basically means at the alpha level of 0.05, there is enough evidence to reject the claim that the mean price is at least $20,500. So that's that's doing this approach with paper and pencil. Let's type it into the calculator and see if we get the same test statistic. So let me pause the video for a second. And let's type this info into the graphing calculator and get this. Let's see if we get the same info. So we'll click the Stat button, arrow over to Tests, and we're going to pick option 2, which is the t-test, and hit Enter. In this case, in the problem we were given summary statistical data, not raw data, so arrow over to Stats and hit Enter. Mu0 is the hypothesized mean that was given to us in the problem. So we were told that we think that it's $20,500. That is going to be our mu0. Basically, this is the value that you plug in for your hypothesis statements. Right below it is x bar. That's the sample mean that was given to us in the problem. And the sample mean we were told was $19,850. And below that, SX is the standard deviation for that sample, which they told us was 1,084. And underneath that is N, which is the sample size. How many cars did we look at here? And they told us in the problem we looked at 14 cars. Now the last part is, what type of hypothesis test are you doing? And this will match your HA statement. So our HA says we're looking to see if the mean is actually under $20,500. So arrow over to less than and hit the Enter key. And then afterwards, you can pick either between calculate or draw. I personally like to do draw only because it actually draws the t-distribution. So it shades in our p-value here. So where it says t equals negative 2.2436, that's our standardized test statistic, which basically matches on the PowerPoint slide what we did by hand. So it actually calculates the standardized t for you. And then over here on the right is our p-value. It says the p-value here is 0.0215. So let's say we use the p-value approach instead of using critical values. Well, if our p-value is smaller than alpha, then we would reject the null hypothesis. Well, 0.0215 is smaller than 0.05, so therefore, using the p-value approach, we would still reject HO. And again, that's enough evidence to basically put an X next to our claim, basically saying we can't believe this claim anymore. So we still have enough evidence to reject that the CRV is at least $20,500. Here's another problem. An industrial company claims that the mean pH level of the water in a nearby river is 6.8. You randomly select 19 water samples and measure the pH of each. The sample mean and standard deviation are 6.7 and 0.24 respectively. Is there enough evidence to reject the company's claim at an alpha level of 0.05? Again, assuming the population is normally distributed. So here they're saying that we think that the mean pH is 6.8, and is means equals. So basically, our claim here, we think, is that the mean, or mu, equals 6.8. The opposite of that would be that the mean is not 6.8. So basically, our hypothesis test is going to test to see if the mean is actually bigger or smaller than 6.8. The alpha level they told us in the problem was 0.05, and the degrees of freedom is sample size minus 1. We took 19 samples of water, so therefore we have 18 degrees of freedom. So let's find the rejection region, our critical value, our critical t value, with the 18 degrees of freedom and the alpha level of 0.05. So we have 18 degrees of freedom and alpha level still 0.05. Let's hit the calculate button. And in this case, we're doing a two-tailed test because our HA statement was the not equals test. So that means our critical value, critical t value, rounded, is going to be positive 2.101 and negative 2.101. So let's go back to the slide. my shaded rejection region graph basically says to me, if my standardized test statistic that I calculate is either more negative than 2.101 or it's more positive than 2.101, I would fall in one of these blue shaded rejection regions, and I would have enough evidence to basically get rid of my HO, reject the HO. So plugging into the formula, we know that, or we're going to end up getting a t value of negative 1.816, and that clearly does not fall in either of the blue shaded rejection regions as the graph indicates. It definitely falls outside. So therefore, based on the comparing t-values approach, we would not reject the HO. We don't have enough evidence. And therefore, we do not have enough evidence at an alpha level of 0.05 to basically reject the claim that the mean pH level is 6.8. Now let's plug it into the graphing calculator and let's get those same answers, okay? So let me pause the video here. Click our stat button, go over to tests, and again we're going to pick the t-test. And again we're dealing with summary data. Our hypothesized mean here is actually 6.8. That's what we think the pH level is. The sample mean in our problem they told us was 6.7. That's x bar. And the standard deviation for the sample they told us in the problem was 0.24. And how many samples of water did we take was 19. And then lastly, what type of test are we running? That's based on our HA statement. And since we're looking at not equals, we say enter on the not equals option and then go down to draw and hit enter. And we can see here that we get the same standardized test statistic as earlier. T is negative 1.816. And our p-value, we are told, is 0.086. So if we decided to use the p-value approach, okay, my p-value has to be smaller than alpha to reject HO. Well, 0.086 is not smaller than 0.05, so therefore I still can't reject the null hypothesis. So again, I don't have enough evidence to get rid of that idea that the mean pH is 6.8. So like I said, you have two approaches that you can use to determining whether or not to reject HO. Personally, I would use the graphing calculator either way, but I think the p-value approach is pretty simple to do because it's pretty easy to compare a decimal to another decimal. And I have one more example. I'm just going to stop the video just so we don't run out of taping space.